All right, so for 1.2, what we're going to focus on today are properties of real numbers. So we're basically going to graph and order real numbers. Now, we said this yesterday that almost all numbers are real numbers. In fact, the only numbers that aren't real numbers are the imaginary or complex numbers, all right, which is the square root of a negative number. So that's most of the numbers, all right. But we gotta get in the habit of being a little more formal, especially in Algebra 2. So we're going to define what numbers that we're going to graph and place in order. To graph an imaginary number, you do a little different. You do the xy plane with the real and the imaginary component. You'll learn that before the end of the year. So I'm being a stickler about the formality of this, and we're going to define this as graphing and ordering real numbers. So basically, we're going to jump right in with example number 1. And remember, whatever I write down, I'd like for you guys to write down. And so problem number 1, they basically want us to classify a number. So it says, listen to me carefully, I'll read it, and then we'll talk about it, and then I'll write it down. But first I want to draw a little chart, okay? So actually, let's get to a fresh new screen, and you can just go a little bit further down on your paper, but let's review what we talked about yesterday, okay? So 1, 2, 3, what are those, if those went on forever? Anybody remember from yesterday? Pattern. Those are natural numbers. Okay? Now, if we go a little bit outside of that, and I think about 0, 1, 2, 3. What do we call those numbers? Those are what we call whole numbers. If I go a little bit outside of that, and I say negative 3, actually dot, 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 negative 2, negative 1, 0, 1, 2. Can somebody tell me what those are? Anyone? Yes. Those are integers. All right, we're cooking with gas so far. Well, a little bit outside of that, what would we call the blue numbers?
Rational.
Rational. Now I gave you a little clue. Remember, rational has the word ratio in it. So I put some fractions in there. You can have positive, you can have negative. I even put the square root of 36, which is what number? 6. 6 can be written as 6 over 1. So that's a rational number. Again, being a stickler, all of these are what we call real numbers. Everything that I wrote on the board is a real number. Why? Because there's no letter I. There's no imaginary number. Somewhere in here I can fit an irrational number. Irrational numbers, we'd have to go, and it's still in the real number category, but it's kind of like off to the side. So it would be like still real numbers, but over to the side here, and we would say pi e the square root of 7. And so those are irrational. So we're going to go back. Example number 1, it says, who could be in this race? Or better yet, who would not be in this race? So it's saying, which set does not contain the number of people in the race. Well, the way the question is worded, which one is highly unlikely? Which one would not be it?
Irrational.
Yeah, we wouldn't have 1/4 of a person, but we could have 2 people. We could have 3 people. So we could have, if we have 3 people, let me rephrase that or reword the question a little bit so it makes a little more sense. I could have 4 people in the race, so let's assume I have 4 people in the race. Is 4 part of this set?
Yes.
Yes. Is 4 part of this set?
Yes.
This set?
Yes.
This set?
Yes.
This set?
No.
No. Absolutely not. So when I word it that way, it becomes a little clearer. Now, how do you think they're going to word it on the SAT? The way Mr. Adams explains it, or this way?
This way.
This